right, so in class we talked about solid proportions, we talked about setting up ratios. This is a continuation on that, and we're looking at how this is applied to more of a real-world situation. So rather than just somebody coming up to you and saying, "What's x over 5 equals 1/4? What is x?" Nobody would ever say that, and so really we're looking at where this is used in the real world. So we've got a map. Maps are a great way to talk with this. And a map has a scale of 1 inch to 18 miles. So on the map, the distance from Chicago to Evanston is 0.625 inches. What is the actual distance? So we know that a map is not to scale. You look at a map of Minnesota, and there's no way that's the actual size of Minnesota. And so we scale things down. In this map, we know that 18 miles in the real world, I'll use my pen here, 18 miles in the real world is the same as 1 inch on the map. So that's a ratio. That's a scale factor that we're given. So we can start by writing that scale factor down. We can write that initial ratio down. 1 inch is the same as 1 or 18 miles. That's a comparison. And we know that that's equal. That ratio has the same value for all the dimensions on the map. All the dimensions that have the same ratio, the same scale. 0.625 inches is the distance from Chicago to Evanston. Now, if we match things up, I want things to kind of match up and line up and look pretty. And so I'm going to put those inches in the same spot as the other inches. So you'll notice that the inches were in the numerator for my initial ratio, 1 inch. And they're in the numerator for my second ratio, 0.625 inches. So inches matches with inches. We want to match things up, which, I mean, it looks nice. It makes sense that the inches would go on top, so the inches go on top. Miles go on the bottom. Miles are in the denominator. And I want to know how many miles is that in real life. I have a proportion. I can solve this proportion. So I'm going to cross multiply here. Now again, you could certainly try and figure out another way of comparing these equivalent ratios, but cross multiplying is probably going to be the simplest way to do it. So 1 times x, that's easy, that's just x. And if I do 18 times 0.625, and again, I'm using a calculator, I'm assuming that you're probably going to use a calculator as well, 11.25 watts. Wouldn't be 11.25 inches. We've already got the scale here. We've already got the, the label here, x miles, which means we do need to label our answer 11.25 miles. In Chapter 2, or the second half of Chapter 2 here, I am going to grade your label. You have to label it correctly. There's a big difference between an inch and a mile, right? If there's 5,280. There's 63,360 inches in a mile. There's a big difference between 1 inch and a mile. And so really we need to be very careful with those labels. So it'll be 11.25 miles. Let's look at another example of that. So a map has a scale of 1 inch to 18 miles. Well, same map probably. So we can start with our proportion. We can start our ratio. 1 inch, and again I'm labeling. That label is extremely important, especially in this half of the chapter, to 18 miles. That's our initial ratio. That's how we're starting our proportion. The actual distance from Chicago to, I don't know how to say that properly, Waukegan is 4 miles. So if I'm filling in the second half of my proportion here, miles, we want miles to match with miles. So the miles is going to stay on the bottom. And we're going to have that 4 in the denominator. It says, what is the distance on the map? We don't know. So that's our variable, and we know that's going to be inches. Okay? So again, I've got a proportion. I can solve this proportion by cross multiplying. 1 times 4 is just 4, and x times 18 is just 18x. Now I'm going to have to solve for x, so I'm going to divide both sides by 18, divided by 18, and x is going to equal 2/7. You could certainly write it as 2/7 if you really wanted to. If you really wanted to get the decimal in there, sevenths are not nice. You have 0.285714, 285714. I'm not going to write that. 4/18, 2/7. However, it is important that we label. And so we're talking about, let's see, X. X was inches in this problem. So it's going to be 2/7 inches. Oh, I'm sorry, it does say round to the nearest tenth. So 2/7 inches, that was 0.285714, 285714. So 2.9 inches. Did I round correctly? Tenths. Ah, there we go. Sorry. Good thing I checked the question again. When you're doing these problems, once you've written down your answer, go back and check the problem one more time and make sure you've answered the question exactly the way it's listed. So, round to the nearest tenth, 0.3 inches. And that's how we use these scale factors with a map. Unit rate. Unit rate. So a unit rate is saying how many per unit. How many dollars per item? How many bushels per barrel? A unit rate. So a unit rate is the rate with the second quantity of 1. Miles per hour is how many miles per 1 hour. So a unit rate means per one of something. How many do we have? You often see this at grocery stores. Something is listed at $3 for $5. They don't do that simply because it's easier that way. In fact, it's harder to do $3 for $5. Why not just list the actual price? And one of the reasons why they do this is because $3 for $5 is not a nice, easy number to do in your head. And so most people won't do it. And what they've found through many studies is that if they list something $3 for $5 or 9 for $8, and they throw these kind of weird numbers in there, people won't do the math to figure out how much it costs for one. They'll just buy 3. 3 for $5, I don't know how much that costs, I'll just buy 3. And they've done studies, and it works. And so the grocery stores and other places know that if they list it for this, there's a better chance that people will just buy 3 instead of just buying 1. So they'll make more money, which is fine. They're a business. That's what they're supposed to do. But we can figure it out because we're smarter than that, and we can actually figure out how much it's going to cost for one item. Now, be careful. 3 for $5. If I set this up as 3 divided by 5, I'm going to get 0.6. However, that's not really what I want. This is 3 items for $5. What I've found is that I can get 0.6 items, whatever it is, pizzas, per $1. Well, that's pointless. I can't buy 0.6 pizzas for $1. They won't sell me 0.6 pizza. I can't take the frozen pizza and chop it into 0.6. That doesn't work. So 3 items for $5 is not going to give me what I'm looking for. So when you're setting these problems up, be very careful of what you're asking, because the question is saying how much per item, how much per dollar, or excuse me, how many dollars per item is this? If you have a money question, especially if you have a money question, the dollars are going to go on top, because we want to know how much money per item. And again, I'm going with pizza here because I like pizza, but it's $5 for 3 pizzas, $5 for 3 items. Now, 5 divided by 3, I'm going to get, again, it's money, so we have to estimate a little bit. I'm going to get 1.67. 5 divided by 3 is going to give me 1.6 repeating, but it's money. So I have to round a little bit. It's $1.67. Oops. $1.67 per, it's not liking me right now, $1.67 per item. I'm going to do another example of that, but again, you're setting up a ratio, and a ratio is a fraction. It's division. So 3 for $5, how much is that going to cost as a unit rate? Well, it's going to be $5 for 3 items. But that boils down to about $1.67 per item. So we can figure out the unit rate, the unit cost. So get another one here. So 7 for $10. So again, I don't want to know how many of the item I can get per dollar. I want to know how much is it per item. So I've got $10 for 7 of them. We'll go with bananas. 7, that's a lot of money for a banana, but 7 bananas for $10. Must be like some really good bananas. So $10 for 7 of these. I'm going to divide. So 10 divided by, 10 divided by 7. And I'm going to use my calculator here because I'm not going to do that one in my head. And since I'm doing decimals, I know that sevenths aren't nice decimals. So 10 divided by 7, I'm going to get $1.43 roughly. 1.42857, 14285. It's going to keep repeating. And so I'm going to end up with $1.43 per item. And you could certainly do it as per one item if you wanted. However, I'm going to write per item so I really know what I'm talking about. Per banana, per pizza. And that's how you get that unit rate. You have to be very careful of what order you're doing things in. So make sure you're asking yourself the question, do I really want to know, and labeling, do I really want to know how many bananas I can get for $1, or I want to know how many dollars it is per banana? And it depends on the problem. That's the question you need to be asking them. Okay, what I'm going to have you do is go ahead and do these 5 questions. This is a review of what we've been doing. Come in for class ready to ask questions. So come to class with these notes done, these 5 problems done, and we're going to ask questions on these 5 problems rather than doing the pretest. Okay, good luck.